Hello there, friends. I'm getting a 3D printer soon, and I've decided that I'm going to 3D print myself a whole bunch of Tricopter components because I can. And one of the features that I've integrated into the design is these LEDs you see in the motor mounts. There's some on both sides and on the tail as well. And it's just three 5mm LEDs kind of snapped into place on each side, but they're tucked in there pretty tight, so I figured I'd do a quick video on just how to do an LED series circuit. And I'll just show you the calculations and how to actually solder it all together so it's neat and tidy. So we're over at my very dirty workbench now. The idea here is that we'll have 12 volts coming out of the battery, nominal. It's a lithium polymer battery, so it ranges from about 11 to 12.5, but that'll be okay. And we're going to have 3 LEDs in each arm, and they're white LEDs which run at about 3 volts forward voltage. They're diodes, so it's a constant voltage drop across the LED, and you have to make sure that you have a resistive component in that circuit to absorb any excess voltage, because that voltage drop across the diode is constant. So if we have 12 volts and 3 3-volt LEDs, we'll have 12 minus 9 volts. We have 3 volts for the resistor. Current through here, they're going to be in series, and it's about probably 20 milliamps nominal current going through each LED. So if we look at good old V equals IR, in that resistor we want to drop 3 volts is going to equal 0.02 amps times R, which means that R is equal to 3 divided by 0.02. So if 1 divided by 0.02 is 50, that means 3 divided by 0.02 is going to be 150 ohms. Alright, so basically we're going to have 12 volts in, we're going to have 3 LEDs, and then our resistor at the end. Okay, let's do that. So I mocked this up initially just to get the scale right. I just put it up against the screen on my computer and I tested it to make sure that I wasn't wrong, and I'm not. It draws about 19 milliamps or so. I think that's actually a 100 ohm resistor I put in there, but the voltage on the battery I was using is a little low. So anyways, it'll be fine. It's close enough. So this isn't quite gonna work. If you saw back on the computer there, it's pretty tight. So I've got 3 more LEDs here, and what we're gonna have to do is bend the leads and tuck a resistor in there nicely to make sure that this all actually fits inside the hole. So if we take our LED, what we're gonna want to do here is grab the leads with a small pair of pliers, and I try not to bend them right at the base of the plastic because you could put a lot of strain on the actual internals. So I'm just going to take some pliers and we're just going to bend it just like that. Okay, and I'm going to cut these leads down to about 1/4 inch each. Now with the next 2, I'm going to do the same thing, but I'm going to leave one of the leads going straight because I know that it's going to be one of the 2 on the side. So for now I'll just do one leg like that, and I'll cut it off again in about 1/4 inch. And I'll do another one to match that. So this is where we're at so far, and we're just going to have to solder these together to kind of match that template I made, and then we'll get a resistor in there. So I've got these sitting in my helping hands now, and I've kind of just arranged them to match the template there. Now notice, if you look inside every LED, there's the kind of fat half and the skinny half. Make sure the fat halves are on the same side, because that's the ground end of the diode, and if you put these 3 LEDs together in series and those aren't all facing in the same direction, the circuit will not work. It'll just block voltage from going in and out. So now that those are arranged, I'm going to get my giant soldering gun because I don't feel like heating up my small one. And we're just going to do a little blast of solder between those leads. So I've got the next one in there now. I flipped the whole thing around, so again, make sure that that little part inside is facing the right direction, the same on all of them. Blast of solder there. So now our LEDs are together and they mostly match the template. So there's the template on the left and what we made on the right. And you can see that it's going to fit inside that small cavity a lot better without the lead sticking straight down. So next up we need to get the resistor. So I've just bent the ground lead over, the idea being that I'm going to take one of my, I think I'll just use a 100 ohm resistor because that's all I have sitting here. But I'll just take one of the resistors and cut it so it's right across there. So I'll trim that arm to about 1/4 inch on both sides and leave the resistor long so we can bend it down afterward. So I've arranged this back in the helping hands, and again we're just going to line up those leads as best we can and get a drop of solder on here. Just like that. So this probably isn't necessary, but just because I can before I bend the lead of that LED down, I'm going to cover that whole ground leg in some heat shrink just to stop it from shorting out inadvertently. So now that that's all done, we'll do our final bend on the leg here with our pliers. Bring that down so it's mostly parallel. And this is what we're left with. We have a good joint between all the LEDs, we have our ground leg protected, now we have the power and ground coming out on the same side. So I'm just going to trim these legs a little bit and then we'll test it. Alright, so the legs are trimmed up, they're long enough for me to get a power lead on there when I install it on the Tricopter itself. So here's a small 11 or 12 volt battery, and as you can see, that works just fine. So I think that's going to look great when we get it on the arm of the Tricopter. Now, to ensure the reliability and longevity of this, you should always take a little circuit like this and just check it afterward and make sure that your calculations are correct. So I have my multimeter on the current mode, and I'm going to complete the circuit with the probes, if I can. And we will see that, oops, there we go. So you can see we've got about 18.5 milliamps. So this battery is a little low. I think it's at about 11 volts, and that means that once it's fully charged at 12.6, we'll probably have, between 20 and 25 milliamps. So that's a fine range for a white LED like this, and that little project is complete. So everything works fine. I know that was a simple little project, but looking at the comments from my other videos, I can tell that there are a lot of people on YouTube that really just want to learn the basics. So let me know in the comments if you like this and if you want me to do more, and thanks for watching.